Good day all. This is the first topic of third term, which is sulfur. Actually, I am going to be very brief because we don't have much reasons attached to this topic. I am targeting oxidations, reduction. So be brief. I'll just pick out some important area and discuss them. You can read the note and then ask your question when you are confused or when you are not clear. Right. Sulfur is a chemical element with a symbol S found in group 6 in the periodic table. It includes its nucleus is composed of 16 protons, 16 neutrons, and 16 orbiting electrons. Having atomic number 32, its shell structure is 286. First shell takes 2 and 8, and the last shell will take 6 electrons. While its electronic configuration is 1s2, 1s2, 2s2, 2p6, 3s2, and 3p4. It is abundant, multivalent, and non-metallic. Under normal conditions, sulfur atoms form cyclic octatomic molecule with a chemical formula S8. Elemental sulfur is a bright yellow crystalline solid at room temperature. Oxidation number range from -2 to +6. That means if the last shell has 6 electrons, sulfur can take 2 electrons from other element or compound so that it will complete its atom so that its last shell will be completed. And if sulfur would take 2 electrons, then in that compound sulfur will carry -2. But if sulfur will agree to give it 6 electrons in its atomos shell, then it is going to carry +6 as its oxidation number. It forms stable compounds with all elements except the noble gas. Occurrence of sulfur. You see the occurrence of sulfur. Okay, you can read on that. Extraction of sulfur, and this is through Frasch process. Extraction of sulfur is carried out by Hermann Frasch in 1891. The procedure is as follows. First, 3 concentric steel pipes are driven through the earth crust down to the sulfur bed or solid sulfur deposit. That means sulfur is in the soil deposited, and this first pipe will be driven through the soil or the earth crust to meet the bed in sulfur bed or solid sulfur. Number 2, we have superheated water at about 180 degrees Celsius is pumped down under pressure through the outer pipe to melt the sulfur. Then the third one, hot compressed air is blown down through the inner pipe to force the molten sulfur and water through the middle pipe. The molten sulfur is allowed to cool and solidify in tubular molds to produce raw sulfur, which is 99.5% pure. Elemental sulfur obtained directly by extraction is known as raw sulfur. This is the experiment to demonstrate what we've just discussed above. This is the Earth's surface. From here down, from this down here is in the soil. Okay, so this is the sulfur bed or solid sulfur in soil. Here is the superheated water at 180 degrees Celsius. When you pour down your superheated water here, to come and meet the solid sulfur here, this superheated water will melt the sulfur. It will melt this sulfur into a molten state. Then here we have our hot compressed air. Hot compressed air will now be blown through here and then come and meet the molten sulfur. The molten sulfur will now be forced to move away with the pressure, move away or moves upward through this arrow pointing upward. The molten sulfur will now follow to this channel and then will be collected here. Here is your molten sulfur. The allotropies of sulfur. Sulfur exists in two allotropic crystalline states called rhombic and monoclinic sulfur, and in one amorphous state called plastic. That means we have three states of sulfur. Two are crystalline and one is amorphous. Two crystalline, one amorphous. And this amorphous is also called plastic sulfur. I remember in organic chemistry where we have carbon double bond, we added sulfur to it. The sulfur break the double bond of carbon and they enter and cause the molecule to be stronger, cause the molecule to be tougher, cause the molecule to be elastic, cause the molecule to be very hard. And that is why we use sulfur in the making of tire. I hope you remember that. Okay, the crystalline sulfur one, we have rhombic sulfur, which is represented with the symbol of alpha. It is obtained by dissolving raw sulfur obtained from your flash in liquid carbon 4 sulfide. Carbon 4 sulfide is the liquid you dissolve your rhombic sulfur. Place in a beaker in a furnace, in a film cupboard. Yes, in a film cupboard. The solvent is allowed to evaporate to produce yellow translucent octahedral crystal. Yellow translucent octahedral crystals. And it is stable at 96 degrees Celsius and melts at 140 degrees Celsius. That is rhombic sulfur. And monoclinic sulfur or prismatic sulfur, it is prepared by dissolving raw sulfur obtained from your flash process in methyl benzene. Methyl benzene is the one you use to dissolve the monoclinic sulfur. It is that methyl benzene, remember, is toluene. Common name is toluene. Remember our organic chemistry where we have the structure of benzene and we have methyl on top. That is toluene. Held in a beaker and warming the solutions on a water bed. On cooling, transparent and needle-like crystals of monoclinic sulfur are formed along the walls of a beaker. That means they are stable above 96 degrees Celsius and melt at 120 degrees Celsius. The structure of rhombic is translucent octahedral, while this one is transparent needle-like. Don't be confused about them. Amorphous sulfur, that is plastic sulfur, it is super cool liquid obtained by pouring molten raw sulfur into cool water continuously to produce non-crystalline and elastic sulfur. That is how these three are produced. They represent the allotropies of sulfur. You can read on their characteristics, read on physical properties of sulfur so that we save time. Thank you, and ask your question when you are not clear. Please, if you are not clear, you ask your question either through WhatsApp, voice record, or just write it. Thank you.